All right. Well, happy Monday. We'll start a new topic. So we kind of took a small. So we were following the Think Python textbook, and we took a small detour to kind of discuss NumPy, pandas, and data visualization with Matplotlib, and you'll get a homework assignment kind of covering those topics and things like that. And then we're going to return back to Python programming, okay? And so this is kind of a big topic, this whole thing of object-oriented programming, and I think it's pretty important as far as Python goes. And so we'll this lecture is also really long, and we'll pretty much spend this whole week on the topic of object-oriented programming. So I lifted pretty much everything straight from the textbook, chapters 15 and 16 in the textbook. So you can read that and review it, and basically I just adapted it to fit onto slides here. Okay, and so we're going to just start off with kind of, Python has its own kind of built-in types. You've got lists, and you've got dictionaries, and these things have their own methods, right? They have their own kind of functions and things that they're able to do. And meanwhile, you, as a programmer, are able to define your own methods, okay? And what we'll do is we will create a type called point, all right? And this is kind of trivial, but we're capable of doing this. And so we'll just start off with this very, very simple example. And so this point will represent a point in two-dimensional space as an XY Cartesian coordinate thing. And if we want to do this, there's multiple ways that we can go about doing this. One is you can just create a variable x, a variable y, and store your coordinates separately. And there's nothing wrong with that, okay? You can also just create a tuple or a list of length 2, and that will also work. Or you can create a new type, and that's what we're going to do. We're going to create a new type, and the whole process is a tiny bit more complicated, but there are some benefits and advantages to this. And when you do this, you use the keyword class. The class is how we define a new thing, and the convention is to capitalize the name of your class. So here we go. This is it. Okay. All you do is you write class, capital P point, and that's going to define a new point. Okay. And now, right now, my point definition is completely empty, but I do put in this is known as a doc string, and this is basically if you ask help, and it will kind of show you the results for help, and this is basically just so it won't throw an error. Because if I do class point colon and then I just hit enter and I put nothing in after it, it'll throw an error. So if you put in a doc string, even though like the definition and actually what the point is doing hasn't been defined, this at least won't throw an error. Okay, so this is our doc string header. Right now there's nothing else, and this creates an object, a class object. And so if you call what is this thing, capital P point, okay, it comes back and says this is a class object, and the full name of this thing is double main dot point. Okay, so it's like underscore. There's 2 underscore characters, and this is called this is known as double under, and this is kind of almost like the environment in which this thing is located. Okay, it's located at kind of at the top level, and so this is known as double under main. All right, and so point, this class object that we've defined, capital P point, is basically a little factory that creates new objects of this particular class. Okay, and so to create an object of class point, you call point as if it were like a function, Okay, and this is why the convention of using a capital letter, and again, it's not required that you use a capital letter, but that's how it's helpful, is so that when you see these functions being called, or when you see the class being called like a function, by seeing a capital, you can recognize that this is going to be a class object. Okay, so anyway, so here I do create an object called blank of class point, and so if we ask blank, now it says this is a point class object, right? And it's located at this memory address. And so versus over here, this says this is a class object. This is basically the object generator. And when it generates objects, it's going to be of this particular class. And over here, when we generate one of these objects, this is this tells us what it is. Okay. And so so you can kind of think of the class generator as like a bank, and then at the bank you can create new bank accounts. Okay, and so so we're calling the point class object to create a new instance of this that we'll call this. This thing is currently called blank. Okay, and when you ask and when you print whatever this instance is, it tells you what class it belongs to and where it's stored in memory. Okay, so once we've done this, we can start assigning values. Okay, as attributes here. So here I can take this object blank. Okay, and I can do blank.x, blank.y, and this is going to just assign numbers or assign values or whatever it is to these attributes .x. Okay, so so this is the syntax is similar for kind of selecting variables from a module. You know, like if you want to call like math.py to get that value 3.14. In this case, what we're doing is we're actually assigning values to named objects, and these would be called attributes. And then later on we can retrieve it. Okay, so here I just said 4.0. We're assigning it to blank.y, and here blank.y comes back with a value of 4.0. Now, when we define the class point, if I go back, right, there's nothing about x or y stored in point. So here we're just kind of assigning values arbitrarily. Okay, you can retrieve it, and so here I'm doing blank.x, and I'm assigning it to basically a global variable or a variable at the top level, x, and this is going to be 3.0. Okay, so that's that value, right? So yeah, there's no conflict between naming a variable x and having an attribute x inside the class. These two things are unrelated. Okay, so here is x is 3.0, right? So we kind of took this. We said 3.0 goes to blank.x. I took blank.x and assigned it to x. And if I change blank.x to 5, x still is 3, right? So this is, they're not like pointing to the same object in memory. It was just over here I took the value currently located at blank.x, and I said take that value and now create a new object called x and assign it there. So now I've got this object x 3.0. Inside memory I've got another object called blank, and within blank we have an attribute x with a value 3.0. I change this to 5.0, and because this object and this object are unrelated, it doesn't matter. Okay? These two things are not affected. You can use the dot notation as part of any expression. And so, oh, you know what? I forgot. This is one notation, but you can kind of earlier I changed it to curly braces dot format. Okay, sorry. This is an older style notation. I forgot to update these slides. But basically, you know, you have the curly braces where you can kind of insert blanks of things like that. You can do that with a dot format, and this is This is the older style notation where you use the percentage sign, and that works too. So here I'm saying take the value blank.x and blank.y and feed that in. This is kind of like dot format, and put that into these placeholders, which are indicated with %g and %g. So those values 5 and 4, which are currently stored in blank x and blank y, can go into here. Okay. And so here I'm creating a new function called print_point, and here it's just going to basically print out whatever this thing will output. Okay. So now that I've defined this, I can say print our point blank, and it outputs 5, 4 to the screen. All right, before I go on and forget, let me go ahead and give you your first view quiz answer for today, and that is the letter B. B as in bear. B as in bear is your first view quiz answer. Oh, those of you who got here a little bit late, I got some candy for you guys, okay? For Valentine's Day. And if you're watching online, you missed out. We got Fun Dip and gummy bears, gold bears, yeah. All right. Take these. You guys know how to eat Fun Dip, right? Okay. I gave my daughter Fun Dip for the first time not too long ago, and she was like, "It works better if you lick the stick." And I was like, "Oh yeah, that's exactly what you're supposed to do." But she was like proud of herself for making this discovery. It's like, okay, yeah, good job, okay. All right. Okay, so what if we want to make a class that will define rectangles? Okay. All right, and so there's lots of, how do you define a rectangle? And there's basically a couple ways you can do this. One is you can specify a corner or a center. You specify a point, and then you specify a width and a height, okay? And so you basically, and which corner you decide to use as your reference, either the lower left corner and the width goes this way and height goes this way, or you define the center and the width and the height and it's there, or you can just kind of specify two opposite corners. There's lots of ways. There's no right or wrong way to do it, okay? What we're gonna go ahead and do, just for this example, is we'll specify a location, and then we'll specify the width and the height, okay? And so here we're going to just create a class called rectangle, and then our doc string says represents a rectangle with attributes width, height, and corner, okay? And so, and to represent the corner, we're going to use a point object, okay? So here, and again, right now, my class definition has absolutely nothing in it, okay? And we're going to just start using the attributes features, or start assigning some of these attributes to the object rectangle. So here I'm going to create an object called box, and then we'll just define, I'm just making these things up. We're going to say box width is 100, box height is 200, right? So it's kind of a, you can think of kind of two squares stacked on top of each other, this tall rectangle. And then, and for the corner, we'll use the point, okay, point object, and we're going to call this box.corner. Box.corner will be a point object, and then to the point object, we're going to have box.corner.x is 0, box.corner.y is 0, okay, or 0.0 as floats. Okay, so far so good? All right, and so now we can write a function that will return some kind of instance of this thing, right? So let's say we've defined, kind of the corner. We'll say the lower left corner, and what we're going to do is we're going to search for the center. So we're going to say 0, 0 defines the lower left corner, and we have a width of 100 and a height of 200. So if somebody says, "Hey, where's the center of this rectangle?" Well, I'd say, "Oh, okay, it's over at 50, 100." Okay, 50 across half of the width plus the x coordinate of the rectangle, and then half of the height plus the y coordinate of the corner. And so we're going to say find a center, and that will accept some kind of object, rectangle, and we're going to define a new point P. P dot x is going to be the x corner plus half the width. P dot y is going to be the y corner plus half the height, and we're going to say return whatever P is. Okay, so we have our box, which currently has a corner at 0, 0, width of 100, height of 200, and we say, okay, well, what is center? Okay, center is now a point object, but we can't actually see any of the values here. But remember, we defined that function print point, and that will go into the point center that we've defined, extract out the x and y coordinates, and it prints out and it says the x and y coordinates of your center is 50, 100. Okay. So objects themselves are mutable. Okay? So you can change the state of an object by making an assignment to one of those attributes. So here I've got box.width is 100, and what I'm going to do is I'm going to just make the box wider and taller. We're going to increase the box width by 50. We're going to increase the box height by 100. So now it's going to be 150 by 300. So now my box.width is 150, and what we can do is we can write a function that will modify objects themselves as well. So here we're going to create a function called grow a rectangle. It accepts a rectangle as an object, and then we're going to add, it takes two arguments, basically a delta width and a delta height. How much do we want to modify the width? How much do we want to modify the height? So we're going to do rectangle.width plus delta width, rectangle.height plus equals delta height. So currently our box width and our box height is 150, 300. We're just printing this out as a tuple. And then we can say, you know what, grow it by another 50 and another 100. Okay, and we can ask what's our new box width and our new box height, and it's now 200 and 400. Okay, and so this is the same object, this is the same box object in memory, and we're just kind of modifying the attributes as we go along. Okay, and so within the function itself, okay, so this is kind of you want to kind of keep this in mind as far as how this function is working. Within the function itself, notice that the argument is called rectangle, right, or rect, and so when we call grow.rectangle and we pass the object box to it, okay, box gets passed in here as under the alias rect, okay, and so therefore when we say rect.width, it's referring to the object box, and it's going to modify the width attribute of the rectangle, which points to the object box. Okay, so whenever the function modifies attributes of rect, it's modifying the attributes of box. Okay, because it's getting passed into the function under this alias here. All right, there's a few. So whenever you work with objects, you got to kind of keep in mind what's happening, and when you're working with the object itself and modifying the object versus when you're kind of dealing with new instances or new objects here. Okay, so earlier we had seen, like with the point, we took our blank point and we did blank dot x, and then we took that value and assigned it to it, created a new object, a new variable called x. And those two are unrelated. But if we were to modify blank, the attributes of blank, that object itself is being modified. So, the fact that objects are mutable can sometimes make code difficult to read, especially if you have, there's a couple kinds of functions, right? Some functions will modify the objects without necessarily reporting or printing anything to the screen, whereas other functions are a little bit more explicit about this kind of stuff. And so, if you need to work with a copy, you can use the copy module to make duplicates of an object. So here I'm going to generate a new point, and again, right now our point definition has nothing in it. So I'm going to just assign attributes. P1 will have the x and y coordinates 3 and 4. I'm going to import the module copy, which allows us to create copies of this. And so P2 creates a copy of P1. Okay. So print point P1. P1 is 3, 4. P2 is a copy of P1, 3, 4. All right. So these are two separate objects. They're copies of each other. Okay. And if I say is P1 the same object as P2, okay. So when you're dealing with objects, the equals is asking, is this the same object? So even though the values inside, the value inside P1 is 3, 4, and the values inside P2 are also 3, 4, as far as the x and y attributes, Python recognizes that these are separate objects. They have different IDs, right? It's kind of like, there's two people, and they're, both of them have a name, John, and they both are, height 6 feet tall or whatever. But are they the same person? They're not. Okay, so you can ask, are they equal? Or there's another function is P1 and P2 are we pointing to the same instance of the object? They're not. Okay, P1 is located at this location in memory, and P2 is located at this location in memory. Which and these memory locations, if you look carefully, they have different memory locations. This one has D26 and this has FF3. So they are different objects, even though they happen to have, they just happen to have the same x and y values. Okay. Remember, when we created a rectangle object, and again, the rectangle class started off empty, but when we create a rectangle object, we have an attribute, and one of the attributes is the corner, and the corner is a point object. Okay? So this is where the difference between a shallow copy and a deep copy become especially important. And I think we talked about this very early on in the quarter, but we'll revisit this concept, this distinction between a shallow and deep copy. Okay, so here we already have a rectangle defined. We've called it box. Box has a width of 200 and a height of 400. And box.corner, I think, is currently 0, 0. Okay, currently located at 0, 0. And it is a point object located at this location in memory. Okay, so if we say what's the x and y coordinates of box.corner, it currently says 0, 0. What I'm going to do is I'm going to start by making, this is what we call a shallow copy. Okay, I do copy.copy box. We're going to call this box2. Okay, is box2 and box1 the same? No, they're not. They're different objects. Box2 is a different instance of the rectangle object than box. Okay, but the corner of box2 is the corner of box. So when you make a shallow copy, this corner, the corner is an object, right? It's a point object located at this location in memory with coordinates 0, 0. The corner of box 2 is the same object as the corner of box 1. So a shallow copy copies all of the attributes, and if there's other objects referenced, it copies the reference. It doesn't make a copy of the object inside. Okay, so that corner in box 2 is the same corner as the original box. Okay, box 2.corner is this corner object. There is point object in memory, and box.corner is the same. You can see the address, the memory address is the exact same object. And so if I were to say modify the location of the x coordinate or y coordinate of box.corner, it will also modify the location of the x and y coordinate in box 2. Okay, because both box 1, box and box 2 have the same corner, and so moving one is going to move the corner of the other object. They're tied together there. Okay, so they refer to the same point object. When you use copy.copy, it creates a copy of the object and the references inside, but doesn't make copies of the embedded objects. So here I'm going to change box.corner.x from 0 to 1. Okay? And so if I ask what's the corner of box.corner.x, I come back with 1. And if I ask what is box2.corner.x, box2's corner has also been modified. Again, if you think about it, when you look at this, I think it's quite clear. They're pointing to the same thing, right? They're pointing to the same thing. So it's kind of like, there's a club on campus, and you have, John Smith is the president of the club, and then somebody says, hey, we're going to make a copy of this club, and it's going to be, we changed the name, and it's something else, okay? And John Smith, the same person, happens to be the president of that club as well, right? And so if, if John Smith, gains $100 or something, and you ask how much money does the president of Club 1 have, it's going to be the same amount as because it's pointing to the same person, right? It's the same person, right? And so this corner of both of these things are the same object. And so, when you change one of the values, x, of this corner object, of course, it's going to change it over here, okay? If you don't want that, right? So box 1 and box 2 are separate, but they share the same point object. So we could change, if I wanted to change the height of box 1, okay? Height of box 1, I can change it to 200. The height of box 2 remains 400, right? So the attributes of these things are different, but that corner object is the same object. Okay. If you don't like this behavior, you can create what's known as a deep copy, okay? So here I'm going to do box 3. Box 3 is a deep copy of the box, okay? Okay, wait, before I forget, your second view quiz answer today is D. D as in dog. D as in dog is your second view quiz answer. Okay, so let's see. Box.height is 200. Box 2 height. Okay, so box 3 is a copy of box. And because it's a deep copy, the corner of box 3 is a corner of the box corner. It's not the same object. So if I say box 3 corner, is it the same as box 1 box corner? They're different objects, okay? It created a copy. It created a copy of the object inside, the embedded objects. And so now if I make changes to box 3.corner, it's unrelated to box.corner because these are separate objects. And if we were to ask, what is box 3.corner, it'll have a new address in memory. All right, so let's talk about functions that interact with our class objects. Okay, so what we're going to do is we're going to create a class called time. And Python already has, or there's modules and libraries that already deal with time and stuff, but we're going to just kind of create this so we can just see some examples here. So here I'm defining a class time. No attributes are defined. It's just here, this is my doc string. We're going to just say we got hours, minutes, and seconds, and we're going to have to do this ourselves manually. So I create a lowercase instance of time. So this will just be some time, and we will say it is 11, 59, and 30 seconds. So the hour is 11, the minute is 59, the seconds is 30 seconds. Okay, and I'm sorry, I'm still using the old style format string. I'll need to update this to use dot format, okay, with kind of the placeholders. But basically we're going to say, we want 2 digits to represent the hour, 2 digits to represent the minute, and 2 digits to represent the second. Okay, and so notice this argument takes in some object t, okay, which if I were to pass time into it, time will get aliased as t, and then we will extract out t.hour, the dot hour attribute from time. Dot minute, dot second, and we have that, okay? And so when you print this out, it comes out as 11, there's a colon, 59, colon, 30, right? So it takes these things and it prints that out. Now, there are, we want to kind of differentiate between different kinds of functions. And you can use either or both, and a combination of these things in Python and other programming languages, but it's kind of good to keep in mind how functions work. And we've encountered these, right? So we have pure functions, and a pure function takes the object passed into it, doesn't touch anything about it, right? Doesn't do anything, takes information out of that object and returns some new value that's unrelated, doesn't modify the object passed to it, okay? And then modifiers will take that object and modify it. So it's the difference between sorted applied to a list, which leaves the list unaffected and it gives back the results in sorted order, versus list.sort, okay? And list.sort will take the list and actually sort the values inside, okay? So list.sort would be a modifier. Sorted applied to a list is a pure function. Okay, this, the author takes kind of a little bit of a detour and just talks about this idea of prototype and patch. Prototype and patch, and this is often a good strategy to employ when you're trying to develop some kind of complicated solution. And so you often start off with a prototype, basically a very simple version of the program that does just the bare minimum, and then incrementally you add little complications to build up into each thing. And every time you add to it, you want to test things out, okay? So here we're going to create a function. And what this is going to do, it's going to take two time objects, and it's going to add them together, okay? Two time objects, and we're going to add them together. And again, it feels a little bit strange, but time is basically a numeric variable. It's just the way we express time is in this kind of this strange format, right? It's like this hybrid base 60, base 24 system where certain units are stored in base 60 and then the other units are stored in base 24. And then the other part is like this weird, keeping track of a year is totally strange. Okay, but what we're going to do is we're going to take two time objects, T1 and T2, and then we're going to define a new time object called sum. Okay, and so sum is going to be a new instance of the time object. And all we're going to do is we're going to take the hours from T1 and T2, add them together, and that'll be sum.hour. T1.minute, T2.minute will add to sum.minute. T1.second, T2.second will be sum.second, okay? And then we will return this sum, which is a new instance of the time object, okay? And so this is just a very, very, very simple prototype, and I think we can already see some issues that we will encounter, right? If this is my solution for adding 2 units of time, right? Like if somebody says this movie is how long are you gonna if you watch 2 movies together, how long is it gonna take, right? One movie is an hour 55 and another movie is, I don't know, 2 hours and 20 minutes. How many hours, how much time total is that? You could use this for something like that, right? Okay, or I guess you could say, we'll start the movie at 9:45 in the morning, okay? Start at 9:45, and then the movie lasts an hour 35. And when are we going to be finished? We'll add the time, and we'll do start and duration. And then when we add these things together, 9 and 1 make 10, 45 and 35 make 80, and so it comes back and says 10 to 80. And we know that's not how we report time. We have to say, okay, this should actually be 11:20 in the morning. So how do we do this? Okay, well, this is not quite right because we got to deal with situations where the minutes add up plus 60, and also seconds can also add up to past 60. So what we'll do is we'll go ahead and we'll patch our function definition, and we will do we'll still have sum.hour.minute.second, and then we're going to say if the number of seconds is greater than or equal to 60, we'll increment the number of minutes by 1, and we'll subtract off 60 from the number of seconds. And if the sum.minutes is over 60, we'll increment the hours by 1, and we'll subtract off 60 from the number of minutes. Okay, and then so we try this out. We take our start of 9:45, add an hour 35, and this looks pretty good. We get 11:20. Okay, so we say, all right, maybe we've solved our problem. Okay, and so so let's take a look. So that would be an instance of a pure function. Here's a pure function where we've taken two objects. We haven't modified anything about these objects, and we're just returning a new object back. Okay, sometimes we want to actually modify the object, right? So here we're going to create a function called increment, and this takes a time object, and we're going to say we're going to add some number of seconds to it, okay? So we're going to say, you know, it's currently 9:45, and let's add, I don't know, 90 seconds. What time will it be in 90 seconds? Well, okay, 9:46 and 30 seconds. Let's add 300 seconds. That's about 5 minutes. Okay, we'll come back and tell us what it is. So here we're going to take just the time.seconds. We will add the number of seconds to it. If time.seconds is greater than or equal to 60, increment the minutes by 1 and subtract off 60. And then if that causes the minutes to go over or equal to 60, increment the hour by 1 and subtract 60 from the number of minutes. Okay. Can we foresee any issues that we're going to run into here? Okay. Well, if you're going to use this approach of prototype and patch, a very important thing is that after you modify your function, you have to go through kind of a rigorous testing regimen, right? So you take the function as it's currently written, and you want to kind of think of a bunch of test cases. And this is a skill that you have to develop as a programmer, is you have to start thinking about all of these strange scenarios, right? And a lot of times, your strange scenarios will be like +1 or +5 and +1,000 or plus minus, 100 or something. And you think of all of these things and you feel like, okay, I think I've covered all of these bases, but then somebody else comes along and they try out a completely mundane task, but it's just something you didn't think about. And it's just something you have to kind of develop, is you have to, a skill that you develop is just starting to think of these different test cases to kind of just make sure your stuff is working. All right, so here we're going to say time is 9:45 and 0 seconds. We'll try incrementing it by 90 seconds, and we get 9:46 and 30 seconds, and we say, okay, that looks pretty good. What if I try to increment it by 185 seconds? That's basically 3 minutes and 5 seconds. And so I'm adding this. So notice I'm trying to add 3 minutes and 5 seconds here. And what happens? So the minute increments by 1, but this part increments by 125. Okay, the number of seconds increment by 125, and that doesn't work if the number of seconds is something, say, over 119. Okay, so it's not enough to kind of carry just once and increment the minute by 1. We have to keep doing it until time.seconds is less than 60, and so, one way we can do it is we could do while statements, and we can just keep incrementing by 1 and subtract 60 every single time. That would work, but it's probably not super efficient. So another way we could do is use modular division and just say, like, okay, how many times? So again, every single time we're just kind of making our function a tiny bit more complicated with each iteration. So here we've got our time, we've got the number of seconds, and we're going to do modular division, right? So we're going to do div modular division, take the number of seconds, do modular division by 60, and this returns a tuple. It returns kind of the whole number part and then the remainder. And so, if I give it, say, 185, the whole number part would be 3 minutes, and I would have 5 remaining. Okay. And then we'll take the number of minutes, and we'll do the same thing in case the number of minutes is this really big amount, and then we'll mod 60 that, and then we'll get the whole number part, which will be the number of hours, and the remainder will be the number of minutes. Okay, and so now we can be confident that the number of seconds or the number of minutes, these values will not be over 60 themselves. Okay, and so we will take the number of seconds, add 60, take the number of minutes, add the number of minutes, take the number of hours, add the number of hours. Okay, and then because these things are not going to be over 60, we only have to worry about the sum being over 60, and we can just increment it by 1 accordingly. So we're going to have time.second over like that and something like that. Okay, and so we'll try this out. Print time, and then we could say take the time, add 185 to it, and this looks like it's working correctly. It incremented the number of minutes by 3 and our number of seconds by 5. So far this looks to be good. All right, what if we try out just another instance here? We're going to add 4,800 seconds, which is equal to 1 hour and 20 minutes. And if we increment 948 by an hour 20, it takes us to 110805. And that seems to be correct. Okay, and then you'd probably want to run a few more test cases, but just for the sake of our lecture, we don't have anything beyond that. Okay, so technically anything can be done with a modifier. Anything that can be done with a modifier can also be done with a pure function. Modifiers are convenient, but they can become harder to debug. Okay. And if you contrast Python to say something like R basically only allows pure functions unless you use reference classes or R6, okay, which if you're in 102A, we covered that. But most of R is just pure functions where things don't modify the objects. So we looked at that kind of this prototype and patch approach for writing functions, and you can also take a planned or designed development. Okay, so I'm going to run out of time. Let me go ahead and give you your last view quiz answer for today. Today's last view quiz answer is E. E as in elephant. E as in elephant. All right. So prototype and patch is great, especially if you're not quite sure where your development path is going to take you. Okay, but the problem with prototype and patch is that a lot of times you write your code, you run into an error, so you write a little bit of extra code to handle that error. You run into another error, you write a little extra code to handle that error. And you get kind of this unnecessarily long and complicated thing, which ends up just being kind of this spaghetti of all of these special cases to kind of fix this situation, fix that situation, this situation, and that situation, right? So an alternative design patch is kind of designed development. And what you do here is you think ahead and you say, all right, what's another way I can reframe the problem? Okay. And so here, we're going to say, okay, let's think about this time issue. And rather than trying to increment things and stuff, what if we converted all of the times, okay, rather than doing like take the number of hours and the number of minutes and the number of seconds and then add the number of seconds, and then if it's over 60, modify it and stuff like that. What if we started off with a time? We just say, okay, we're going to start at midnight. We're going to call that 000, and then we'll take a time, let's say 2 in the morning, and we'll just convert it to how many seconds that is after midnight. So each hour is what, 3,600 seconds. So 2 in the morning would be 7,200. So we're going to take the time, convert it into seconds, and then you can take basically any two. You take a time, convert it into seconds, you add the seconds, which are just integers at this point, and then you have a function to go from integers back into a time. Okay, so that's another way to kind of frame this. So we're going to say, let's create a function called from time, convert it into integers. Okay, number of seconds. So we're going to say we're going to take the number of minutes. We'll take our current hour, multiply it by 60, add the number of minutes. And then we'll take the number of minutes, multiply by 60, add the number of seconds, and then return the number of seconds. Okay? And then we create another function from integer number of seconds, back to a time. And this will be done by kind of doing modular division with the number of seconds to create the number of minutes and seconds, modular division with the number of minutes to create the number of hours and the number of minutes, right? And so this is kind of just a different approach, perhaps a little bit more elegant. But we are out of time. So we'll pick up from here on Wednesday, and we'll continue our discussion of object-oriented programming in Python. Okay, well, happy Valentine's Day, everybody. I hope you enjoy the rest of your day. We'll see you on Wednesday. We have a question.
Are we just going to finish this lecture on
What's that?
Are we finishing these notes on Wednesday?
Yeah. We'll finish these notes on Wednesday. Yes. And then I'll post a new homework assignment tonight. So be on the lookout for that.